Hello everyone, Mrs. Ruscio here with the 6.1 Intro to Quadratic Functions notes. If you need any type of reference to what's going on with vocabulary, the top of this page is going to be very helpful. But we're going to talk through this throughout the video, and you are going to recognize a lot of these vocab words are from Unit 2. All right, exercise 1 says using technology, we're going to graph this f of x function and then create a table of values with, meaningful points. So I'm going to take out my highlighter and highlight the word meaningful. Meaningful means that we want to include the vertex in there. We don't want just a little side of the parabola. We want to capture the u of the parabola in the table, which in return is going to let us put it on the graph. So I graphed it over here, and in order to find the u, we are going to look for the vertex and then the pattern when the y values start to repeat. I can already see it's happening. So -3 and -3, 0, 0. By gosh, by golly, we found it. So when I do this, I will actually put my vertex in the table first. And then I'm putting all of my x values to the left and to the right. But you can see I didn't just start at 0. It happened to work out this way, which is great, but it doesn't always work out that way. We always plot the vertex first. Oh, wait a minute. The vertex, isn't that a vocab word? Let's put it down here. 4, -4. All right, so now I'm going to fill in the rest of my points. So 3, -3, and so on and so forth. The nice part about a parabola is these points all play matchy-matchy with one another. So if this is -3, that's going to be -3. If that's a 0, that's a 0. If this is a 5, this is a 5. If this is a 0, 12, that's going to be 8, 12 because of that symmetry. All right, I'm going to pause the video. I want all of you to pause it and graph, and then we'll meet back up again in just a moment. All right, here is my beautiful graph. Check it out. I labeled it with f of x. This was just so beautiful. All right, my turning point was at the point 4, -4. Well, here's a news flash for you. The vertex and turning point are the same thing, potato, potato. So if your vertex is 4, -4, your turning point is 4, -4. The maximum, we use the vertex and turning point to get it, but the maximum is always going to be the y value. So I'm going to say this is a y value. The maximum, well, it's not a maximum. The maximum's infinity. So we always look at the vertex, and our y value is -4. Let's circle it. This is, or I'm going to put a box around it, a minimum. All right, switching gears now. The roots we talked about in the polynomial unit. They're the x-intercept x values. So my roots here are going to be at x equals 2 and x equals 6. Roots and zeros, potato, potato again, x equals 2, x equals 6. Y-intercepts are very similar. X-intercepts are very similar. However, the x-intercepts are points. So I'm just going to take some notes down off to the side. So this is a point 2, 0 and 6, 0. The y-intercept is a point, and that's a point 0, 8. 0, 12. You can see it in the table here. You can see it on the graph there. The axis of symmetry. Okay, we haven't talked about this in a while, but the axis of symmetry is that line that slices our function right down the middle into two, like a butterfly, like two parts that would fold on top of each other. And what do we notice? Well, it's cutting the x value of 1, 2, 3, 4 every single time. Notice how we can get that axis of symmetry from our vertex, y value. The range, this is a cool part, the range we can actually get from the vertex also. So the vertex plays a big deal in a lot of other vocabulary words. The range we can get from the y value of our vertex. Now the range, remember, are y values. How low does it go to how high does it go? We'll check it. This is how low it goes, and it goes high, high, high to infinity and beyond. So there is my y value of -4. And what do we notice about all the values? Yes, they're bigger than or equal to -4. Cool. Let's move on to the next page. How am I going to get there? Where'd it go? Oh, there it is. All right. All right. Here we have exercise number 2. They gave us a function. Sorry, my screen is like, I don't know what's happening right now. How about we just do this? All right. Here it is. So on exercise 2, they give us a table. Oh, this is interesting. Okay, so we're going to have to get all of the information without being able to visualize it on a graph. So it says, what are the coordinates of the turning point? Well, we're going to look for that symmetry. There's a symmetry. Here's a symmetry. Do you see that going on with my y values? 12, 12, 9, 9. So 2, 13 is the turning point. The range. Oh, the range we can get from that y value, can't we? The range is always what compared to 13 here? What's going on? 12, 9, 4, -2. Those are all smaller than or equal to 13. Interesting. All right, so if they're all smaller than it, wait a minute. I think my parabola is going to look something like this. So what kind of point would that be at the top? Yes, it's going to be a maximum. All right, axis of symmetry, remember, is going to be this line that slices the parabola in half. Slice is not a very mathematical friendly term, but I think it helps to understand it. Let's see, 2, 13 is that point. So the axis of symmetry, we're going to have to cut through all of the x equals 2 points. Okay, so we're going to get it right from the x coordinate, remember, of the turning point. F of 4, oh my gosh, we haven't talked about this in forever. X is 4. When x is 4, y equals 9. Excuse me. For f, it says, for what value of x? All right, so we're looking for an x value. Is f of x equal to 4? Oh, this is the other way. This is our y equaling 4. Our y equals 4 here. So my x value is 5, but let's not get tricked with this. My table still goes on and on forever, and if this is a 4, wouldn't this be the point -1, -1, 4? So, oh my gosh. I think we have 2 of them. X equals -1. That was really tricky. There's both of them there. All right, exercise 3. Last problem. They want us to graph it, which I did. Check it out. I had to change around my like my axis, all my scales. You are going to do that too when you graph this on your calculator with me. They want us to graph it over this domain. So hold the phone. We don't have to graph this like over here or over there. We only have to graph it from 0 to 8. Interesting. All right, so you know what? Let's create a table of values together. And then I am going to have you pause the video and fill them in. So what do we have to go? 0, 1, 2, 3, and instead of 4, I'm going to leave a space. You'll find out in a moment. 5, 6, 7, 8. All right, pause the video and fill in the table. All right, check it out. Did you see how it was a little tricky to find in the table? Because there wasn't like a point that everything was showing that symmetry around. But I saw the repetition happen. So it means that I'm going to have to go into my menu, analyze the graph, and find that maximum manually because it didn't show up in my table. And there she is, the point 3.5, 20.3. All right, so here's the deal. I want you to pause the video now, graph it, and answer these questions on your own this time. Can you handle it? Yes, you can. Good luck. All right, here's a picture of the graph. I just wanted you to take a peek, noticing that there is not a weird little flat line at the top of this. It's obviously rounded. Another thing that I wanted to point out was that my y values I had to count by 2. All right, you can pause it again, start working through the questions if you haven't done that already. Okay, here are the answers. So I don't know what that's about. All right, what is the range over this domain? How low can you go to how high can you go? Notice that my lowest y value is 0 and my highest y value is 20.3. You can see it in the table. You can see it in the graph. What is f of 0? We're looking for an x value of 0, so my y value is 8. What are the zeros? Okay, this is different. The zeros are the x values. They actually happen to be the same in this problem. That was weird. That doesn't always happen like that, but that was kind of cool. So there's my 0, x equals 8. Notice how we didn't care about the 0 over here. I'm looking at my graphing calculator. We didn't care about the -1 because it's not in the domain. The vertex, that's my turning point. We talked about that already. There she is, 3.5, 20.3. What's the axis of symmetry? It's just this x value, or x equals the 3.5. It's that line there. Notice how it's x equals, it's not 3.5, it's x equals 3.5. And then we haven't talked about this in a while, so let's just touch on it. Over what domain is this function going down? Check it out. My function is decreasing in this little highlighted window here from 3.5 to 8. From 3.5 of my x value to 8. They are x values that we're looking at, not the y's. I just yelled that at you. Don't make that mistake again. Just kidding. Hopefully you didn't make a mistake. All right, that's it for the video. Hope you enjoyed it.